Hello and welcome to your channel. My name is H. This is my first regular expression, also known as Reg-Ex, training video. Regular expression is a language with many different flavors which can be used to capture patterns within the text files. The tool I am going to use throughout this tutorial video is Regex101.com for testing and validation. I'm also using PCRE2 flavor for this video. In upcoming videos, I will explain Reg-Ex in more details with examples which can be used in real-world DLP challenges. Help you to develop your skills around capturing patterns in well-known files such as text, Word, Excel, PDF. We'll also use PowerShell in my videos, which helps to convert different files and develop a tool for DLP solutions. I also welcome any request for specific challenge you might have at your workplace or project, so please ask in comment area and I will answer to the best of my abilities. In this video I will cover the following 7 groups. Group 1, Basic Character Classes. Group 2, Custom Character Classes. Group 3, Anchors or Position Assertions. Group 4, Quantifiers. Group 5, Groups and Capturing. Group 6, Escape Special Characters, need \. Group 7, Lookarounds, also known as zero-width assertions, which includes negative or positive, look behind, and negative or positive, look ahead. Group 1, Basic Character Classes. I want you to pause and read the explanation of each filter in the text file on the right side of the screen, especially the equivalent of each filter if any. It can help understanding the filters during this course. Let's begin. Dot for capturing any single character, except newline in most engines. As you can see, by using dot as a filter, it catches everything inside the text except newline. Works like a wildcard asterisk with one exception, which is newline. \d for capturing any digit. This is to capture a single digit between 0 and 9. You see 101 is highlighted, which means 3 single digits are captured and not the number 101, and it uses different shade of blue to demonstrate it. I scroll down to see what other digits are captured. \D for capturing any non-digit. Pay attention to the caret sign, which is used to reverse the search, which in this case is a single non-digit. In this example, \D reverses the \d and it included newline, etc. \w for capturing word characters such as letter, digit, and underscore. This is to capture a single character. As you can see, it captures all upper and lower characters, all digits, and underscore. \W for capturing non-word character. \W reverses the \w, no A to Z, no digits, and no underscore. \s for capturing whitespace such as space, tab, or newline. This filter is being used frequently in Reg-Ex world, which will be demonstrated in future videos. \S for capturing non-white space. \S reverses the \s. In this example, space and newlines are visible but tab is not, but in real Reg-Ex scenario tab will also be captured. \n for newline. This filter captures the newline or line feed, also known as L. F. \t for tab. This filter only catches tab character ASCII 9, which is horizontal tab. In our example it doesn't exist or it's invisible. \r for carriage return. This filter only catches tab character ASCII 13. In our example it's invisible. And to catch both carriage return and line feed together, \r. \n can be used together, which cannot be seen in this example, but it will be captured in a real Reg-Ex scenario if needed. Group 2, Custom Character Classes. Open bracket, lowercase a, b, c, bracket close, to capture any of the 3 characters, A, B, or C. In lowercase. It goes without saying that to capture uppercase A or B or C you need to change them to uppercase. Open bracket. Uppercase A, B, C, bracket close, to capture any of the 3 characters, A, B, or C in uppercase. Any other combination also works, such as lowercase a, uppercase B, lowercase c. The number of characters you can use between brackets is not clear but enough for what we want to achieve. We can also use dash to specify a range for the filter. In this case we can use lowercase a, dash lowercase c, which does the same. Here is another example which gives you a better understanding of these filters. First I look for a word, video, and you can see that all the word video is highlighted in the text. Then I surround the word video with brackets, which means it's going to catch each character in this word instead. The rest of the filters in this class will give you a more clear picture. Open bracket, lowercase a, dash lowercase z, bracket close to capture any lowercase letter. Open bracket, uppercase a, dash uppercase z, bracket close to capture any uppercase letter. Now the digits. Open bracket, 0-9, bracket close. This filter catches any digits between 0 and 9, which is equal to backslash lowercase d, so they are interchangeable. Next filter is to combine two filters. Open bracket, lowercase a, dash lowercase z, uppercase a dash uppercase z, bracket close, to capture any letter regardless of its case, uppercase or lowercase. Last and not least, negation. Open bracket, caret sign, lowercase a, lowercase b, lowercase c. This filter catches anything other than lowercase a or b or c. In later video I will explain how you can capture caret sign itself. Group 3. Anchors. Caret sign. This character represents start of a string or line, as it's shown on the screen. If used alone, it highlights the beginning of each line. Can be used when looking for a string or pattern which has to be at the start of a line or string, not in the middle. In this example I will search for the word help with capital H. As you can see there are two of them. One at the start of a line and one in the middle. Let's try it with caret sign. It only highlights the one at the beginning of a line. Let's try with the word backslash. There are many of them. I scroll down to see more catches. All the words are captured regardless of their position in the text. Now I try it with caret, which will lose the one in the middle and highlights those at the beginning of the lines. Anchors are widely used in real-world regex scenarios. We move to the next one, which is $. It represents end of the string or line. It catches words or letters which are at the end of the line or string. I start by looking for a lowercase s. And as you can see there are many of them but not all at the end of the line. Now let's try it with $. Now it only catches the lowercase s at the end of each line. Next one in line is backslash lowercase b, which used for word boundary. Backslash b is a zero-width assertion. That means it does not match a character. It matches a position with one thing on the left side and another thing on the right side, as it's shown on the screen. It highlights every word boundaries, left and right. Let's search for the word name. All lowercase. 6 lowercase name are highlighted. 3 with space at both end and 1 with AD at the end, and 2, which are part of a longer strings. Name tag and surname. Now if I add the backslash b in the beginning, result stays the same except in the word surname, because the lowercase r before it is a word character. Now I remove backslash lowercase b from the beginning and add it to the end. As it's illustrated, one of the catches disappears because it does not end with non-word character. It ends with d. Interestingly, the name in the word name tag is unmatched and the word name and surname is highlighted because it ends with space. And of course if we add backslash b to both beginning and end of the word name, only 3 words will be caught. They are all between 2 spaces. Remember that space is non-word character. I like to remind you about the backslash lowercase w and backslash uppercase w. When I mention word character I am referring to backslash lowercase w. And for non-word characters I'm referring to \W. I kept repeating word and non-word characters. Let's find out what it means in practice. If a word starts or ends with anything but A to Z upper or lowercase or a digit or an underscore, it won't affect the \B. In this example I search for the word B with \b at both ends. If I add any of those characters to the beginning or end of the word name, the filter still works. First I add a special characters add sign to test and then exclamation mark. The filter works. The word name is still caught by the filter because special characters are non-word characters. Now I add underscore. Underscore is a word character, so the filter uncaptures the word name with underscore behind it. Now \B. In regular expressions, the sequence \B is an anchor that asserts the position is a non-word boundary. A non-word boundary occurs at any position that is between two word characters, letters, digits, or underscore. And more importantly, between two non-word characters. \B inverse of \b, in other word. Non-start of word or non-end of word. I add few lines to the text to demonstrate the difference between them. In the sentence quote, a cat is in the kitchen, the word cat has non-character before and after. Now I search for cat with b, and the word cat is highlighted. Now I change to B instead. Interestingly, the word cat was captured by b disappears and cat in the middle of the word scattered is being caught. The reason is that this cat is surrounded by word characters. Now let's look for dashed with b. This part needs your focus and remembering what I mentioned before. \B. Inverse the \B. Let's type \B, --B. It matches dash in both phrases color code and passkey. Now I change it to uppercase, and as it's illustrated, no dash is caught. Now I put space between the dash. What we see means a non-character surrounded by non-characters which is caught by B. If I change to lowercase, the dash will not be caught but b. To better understand it, you can make your own text and practice until master it. Now I move on to \A. The regex meta character \A is an anchor that matches only the absolute beginning of the input string. It is useful when you want to ensure a pattern matches from the very first character of the text, regardless of line breaks within the string. \A consistently matches only the absolute beginning of the entire input. At the beginning of this session we discussed caret. Caret matches the word at the beginning of the line. Let's compare them in action. I search for the word hello. There are 3 of them. One at the beginning of the input text, one at the beginning of a string, and one in the middle. Let's try with caret first. As it's being shown, we have 2 catches and the one in the middle and unmatched. Now trying with \A. As illustrated, only the one in the beginning is highlighted. And even if I add space before hello, we get no match. I suggest to pause if needed and practice on your own before moving forward. Last anchor is \Z. Similar to caret and A for the beginning of the screen. $sign and Z work with the end of the string or the whole text. \Z catches if the pattern exists at absolutely end of the text. I look for s followed by $sign. All lowercase at the end of each line or string are matched. Now if I change the $sign with \Z, none of them are matched, except the one at the end of the text. I scroll down to demonstrate it. This concludes the Reg-Ex anchors training. Group 4. Quantifiers. A Reg-Ex quantifier modifies the preceding element of a regular expression, specifying how many times that element must occur for a match to be successful. This group is relatively shorter and easier to grasp. Let's start with asterisk. Asterisk is an aggressive quantifier, which means the preceding element can occur between 0 and more times. I look for s followed by any number of s. It catches single and double s. Why single s? Because asterisk means 0 or more. Now I add few lines with numbers in it, it will be useful for our purpose. Now I look for number 1 followed by any number of 9. As it's being illustrated, all lines are matched. That's the reason they call asterisk greedy or aggressive. Now plus sign, which matches one or more occurrences of the preceding element. Using the same example and changing asterisk with plus sign. As illustrated, the first line is eliminated because there is 09 after it. But rest of them are matched. Let's go back to SS asterisk example again. Now we change asterisk to plus sign. Only 2 are matched. If we add one S to the word expression, it would also matched. Next in line is question mark, which means 0 or 1. SS question mark catches those with single S and double SS. To deal with more occurrences, let's try with 1 and 9 again. 1 in first line is matched because question mark means 0 or 1. In other lines 19 is matched and not the other 9s. So far we covered wildcards. Now we start with more controlled quantifiers. And at the end I will cover more wildcard combinations. Brace. N. Brace, this quantifier means the preceding element can occur n times only. I use single lowercase s. Brace, number 2, brace. Lowercase s, brace, number 2, brace catches double SS anywhere in this text. I scroll down to see other matches. If I change 2 to 1, you will notice that 2s in the word expression is matched with different colors. Which means 2 single s and not 1 double s. Now I change it back to 2. Based on what I just explained, the next 2 quantifiers become self-explanatory. Brace. N. Brace means minimum n times occurrences and maximum can be any number. I look for number 1 followed by minimum 2 9s. By looking at the catches, it's easy to understand how it works. Let's switch the gear to the next one, which has minimum and maximum occurrences. Brace. N. M brace means minimum n times and maximum m times. I look for one with number 1 followed by 3 to 5 9s. The results are self-explanatory. The next 3 quantifiers are not frequently used. It shows how? Turns the greedy quantifiers to a lazy quantifier. They must have been created for a more specific use cases. Question mark in all 3 quantifiers translate to but as low as possible. In current example, by adding question mark at the end, it falls back to minimum, which is 3. If I use brace 2, brace, which captures 1 along with minimum 2 9s and more, you witness the greedy version. And then add question mark at the end. It falls back to the minimum, which is 2, and turns to a lazy filter. If this video has a high pace, I suggest to pause and exercise at your end before moving to the next item. Also, please ask questions in comment area and I will answer to the best of my abilities. Group 5. Groups and capturing. A Regex capture group is a way to treat multiple characters in a regular expression as a single unit, while also saving the portion of the text that matches the group for later use. They are created by enclosing a subpattern within parentheses. Regex groups, defined by parentheses, to organize patterns and apply quantifiers like plus or asterisk to multiple characters. And also capture matched text for later use, like extraction or back references. I have added the text for each section beforehand and I will use them during this session. For capturing groups, I search for the string of ABC. As it is shown, it matches 5 strings of ABC. Now I create a matching group by adding parentheses. The color changes from blue to green, which means group match and 5 catches. It's important to realize that with parentheses it is matching and also grouping. In this example we have 1 group and 5 matches. Once more, if the pace of this video is fast, please pause and exercise at your end before moving to the next item. Now, non-capturing groups. A non-capturing group in a regular expression is used to group parts of a pattern together for applying quantifiers or alternation, but without storing the matched text in the final result. Non-capturing group is defined using the following syntax. Open and close parenthesis, encloses the group. Question mark and colon immediately after the opening parenthesis indicates that the group is for grouping purposes only, not for capturing. The best example I came across is to extract the ID from an email address. We are going to work with texts related to non-capturing groups. Let me copy-paste the filter from my notes. The first part \lowercase w plus is a capturing group because it's between two parentheses. Is a capturing group, and that's what we need. The domain is a non-capturing group. .com is there because we like to capture the ones ends with .com and nothing else. An important side note. We can use the OR sign to capture more domains and routes. In this example I will add edu extension by using parenthesis and OR sign to match more root domains. I can also add more domains using the same method. Let's add Yahoo to the mix. In all 4 lines only the ID in green color are captured and the rest will be ignored. Now it's time for name capturing group. As it was mentioned before, capturing group sequence numbers is based on their appearance. First capturing group would be 1, second one 2 and so on and so forth. The reason we name them is because in a complex Reg-Ex scenarios you can have a group of groups. And it would be hard to remember and follow the numbers. It would be much more convenient to use names. Reg-Ex offers 2 ways for naming the group. Group name between less than and greater than signs. Group name between single quotes. We start using the sample texts for naming capturing group. Now I create a capturing groups for year, month, and day. As illustrated. First group contains 4 digits for year. Second group contains 2 digits for month end. Third group contains 2 digits for day. When I hover the mouse over the captured group, you can see that green group is number 1. Orange is group 2 and purple is group 3. Now I name them by using less than and greater than signs. Give me a second to paste the filter. Now if I hover the mouse over the colored group, you will notice that the group name appears in their description. Cool. Isn't it? Let's explore substitution to better understand how it works in this environment. Please pay attention to the date in gray area and how it changes when I use group names. In substitute I am asking to find these groups and change their orders using the group names. In this example I am changing the date format in original text to day-month-year. The format of the date in the gray area is changed or substituted. The year-month-day format in original text is substituted with day-month-year in gray area. In substitute section groups also can be addressed by their number. Using their numbers also change the date format in gray area. Let me change the filter to prove it. The last item in today's list is \k. For this item we are going to work with \k section of sample texts. Now I create a filter. First I create capturing group called clips for a single quote between braces. Next to it is the word book with capital B and the end \k with reference to the group name clips. The word book between single quotes ID captured. Now I add double quote to the capturing group. 1 second. Now the word book between double quotes is captured. You need to remember that characters inside braces are not group, it means any of these characters. Now I add dot. As illustrated all the books are captured. We are down to the last item. On the right side we have a small section called alteration which I actually used it for demonstration without explaining it. It's a logical or which can be used in Reg-Ex when needed. This concludes Group 5. Group 6. Escape special characters. In this session, we are focusing on a fundamental concept that every Reg-Ex user must master. It's called escape special characters. When you're searching for patterns in text, sometimes you need to match characters that have special meanings in Reg-Ex. Characters like the dot, the $sign, or the asterisk. But if you use them directly in your pattern, they won't match what you intend. They'll perform their special function instead. The solution is to escape them. We add a / before the character to tell the Reg-Ex engine. Treat this as a literal character, not a special one. Let's explore exactly which characters need escaping and see practical examples for each one. 15 special characters in Regex are highlighted at the right side of the screen. I created sample text for each items with a headline to make it easier and faster to explain. When working with each special character, please only focus on the related sample text. I start with dot. Dot alone means anything but new line. But if we are looking for dot itself, we need to escape it by backslash. As you can see, all the dots within the text is highlighted. Now I use a pattern to extract the version of the release from the sample text. With this pattern we specifying dot by using backslash to escape the function. One or more digits. Literal dot. One or more digits, a dot again, and one or more digits. What we just explained applies to all special characters. Please pause and practice at your end if needed. Next one is asterisk. Please focus on the related sample text. With backslash asterisk we catch all of them in the formula. Let's try a new pattern. I need a second to paste it. We matched all multiplications in this equation. First one digit or more. Then backslash s for 0 or more white space. Then literal asterisk. Then backslash s for 0 or more white space, and at the end one or more digits. If I remove spaces around asterisk, the pattern still works. It's amazing that Regex can be simple and complicated at the same time. Time for plus sign. With backslash plus sign we catch the plus signs in C++. Now we use a pattern to catch the C++. First any word character, then literal plus and literal plus again. This pattern matches and single character followed by 2 plus sign. I add B++ and it will be matched too. Question mark is next. With backslash question mark we can catch it in the sample text. Now to catch any word ending with question mark I use a different pattern. In this case the word test with question mark is matched. As side note, what if there could be space between the word and question mark? First I add a space in sample text. Now I add a space followed by a question mark to the pattern. It means space if any. Now we match the word with question mark with a possible space between them. It will match test and question mark even if there is a space. Open parenthesis is the next in line. With backslash open parenthesis we match all of them in the text, just like the others. Now I use a pattern which catches the phone numbers in sample text. Literal open parenthesis. 3 digits. Literal close parenthesis. 1 space. 3 digits. Dash and 4 digits to complete the pattern. As it's illustrated. Both phone numbers are matched. Side question. What if there is a dash between numbers? I want you to pause and think of it for a bit. We have done this before. Using braces and add all possible occurrences. Let me demonstrate it. I need a second to paste the pattern. With this pattern the separator can be space or a dash. You might be thinking of a different pattern. Please go ahead and test it. I explained both open and close parenthesis. But I have a sample text and a different pattern for closing parenthesis. Please focus on the sample text for closing parenthesis. Give me a second to paste the pattern. Literal open parenthesis. 1 or more characters. Capture group for literal dot and 1 or more digits if exists. And literal closing parenthesis. The question mark after capturing group means 0 or 1. In this example capital A is selected because of the question mark after capturing group. This example is very straightforward and easy to understand. But it also opens the door for more questions. Please get creative and practice at your end until you master it. Practice makes perfect. Open and close brace or curly braces are exactly the same. First I use a pattern for open brace. 1 or more characters. Literal open brace. 1 digit or more. Literal close brace. It works on both sample texts. Now it's time for curly braces. With backslash open curly brace we find all of them in the text. Let's try a pattern that matches any word that ends with open curly brace. Let me paste the pattern. 1 or more characters. whitespace, literal open parenthesis, whitespace, literal close parenthesis, whitespace and then literal open curly brace. The word function, two parentheses and a curly brace is matched. For closing curly brace I have a different sample text and a pattern. Let's see what it does. I will paste it first. Semicolon, whitespace and literal closing curly brace. This example is very specific but shows what patterns can do. Backslash itself. We use this to escape. Now we like to catch it. Capturing backslash is part of many regex scenarios. Let's see why. Please pay attention to sample text. Using backslash twice will capture all the backslashes inside the text. Now I paste the pattern. The example and the pattern reveals how often we may use this in real world. Let's break it down. Any character. Colon. Literal backslash. Any word. Literal backslash. Any word. Literal backslash again. Any word. Literal dot. And any word again. In this example, it is capturing the full path of a file on C drive, but there can be numerous use cases. Logical or may not be exercised widely in regex when it comes to DLP, but it has its own domain of use cases. Backslash pipe will capture all pipe signs. Now let's see if we can catch what it is piping. Pasting the pattern. Any word. Whitespace. Literal pipe sign. Whitespace. Any word. Backslash lowercase s with asterisk is to catch and whitespace before and after the pipe sign if there is any. It will match even if we remove the spaces. Because asterisk means 0 or more. I want you to work more with backslash lowercase s. It's being used widely in DLP scenarios. Caret sign seems to be useful in mathematical equations. So I picked the mathematical sample text. Backslash caret is capturing all carets inside the text. Now with a pattern we capture the arguments before and after caret sign. And character. Literal caret. Any digit. You can exercise at your end and match the whole equation. It will be helpful. $, like other special characters, has a function. We used it to find a string at the end of each line. Here we are looking for price tags. Backslash $, matches all $ inside the text. What if we need to match the prices and not only the sign? Give me a second to paste the pattern. Literal $. 1 digit or more. Literal dot. 2 digits. As illustrated, the prices are matched. By looking at the example and the pattern you can tell how frequently it can be used in real-world scenarios. Last special character is /. Once again, by looking at the example you can guess how useful it can be in real world. Backslash / matches all /. Let me paste the pattern and then we go through it together. HTTP or HTTPS. The lowercase s and question mark makes the s optional. Colon. To literal /. Any word literal dot. Any word. Literal /. Any word. Literal /. Any word. And literal /. Any word at the end. Don't forget to pause during the videos and repeat if needed. Also make sure you practice on your end if regex is or will be an important part of your tasks. This concludes the escape special character part of this tutorial. Group 7. Lookarounds. Zero width assertions. Welcome to the final, and perhaps most powerful, concept in our regex series, lookarounds. Up until now, every part of our pattern consumes characters as it matches. Lookarounds change the game. They are zero width assertions. They check if a pattern is ahead of or behind the current position, without moving the cursor and without including those characters in the match. All 4 types of lookarounds are highlighted in the left side of the screen. Positive look ahead. Uses question mark and equal sign. It means This need to appear after the item you are looking for. Before I accept it as a match. Negative look ahead. Uses question mark and exclamation mark. It means this should not appear after the item you are looking for. Before I accept it as a match. Positive look behind uses question mark and less than and equal signs. It means this need to appear before or behind the item you are looking for. Before I accept it as a match. Negative look behind uses question mark and less than sign and exclamation mark. It means this should not appear before or behind the item you are looking for. Before I accept it as a match. I start with positive look ahead. I have picked some sample text and created pattern to explain this item. E1 to E9 will have a different pattern. Let me paste the pattern. In this example, pattern only matches the word sunny if the word today is ahead of it, with one space that separates them. If we want to match with space and dash, we can change the pattern to support it. Let me demonstrate. First I change the space with dash in the text. Now I add space and dash between braces as possible characters in the pattern. The new pattern will catch the word sunny separated by space or dash. Cool, isn't it? For the next sample text we only match as the domain that we want is after the text we are searching for. As illustrated, the support is matched and sales in sales@example.net is not. In next example text, we only match if the word after what we are looking for ends with ly. The word run is matched because the word quickly ends with ly. If I change the dictation of the word quickly, the word run will be unmatched. Next example has prices for items and some of them are on sales. The goal is to match those on sale, and not the other items. Let me paste the pattern. Literal $, any number. Literal dot and 2 digits at the end for cents. As illustrated, only price for items on sale are selected. Next example shows how we can select items which has a specific word such as to do after them and not the one with done. Let me paste the pattern to illustrate. Only first and third double forward slashes are matched. Just think of what you can do in real DLP world with these patterns. Next sample text with hash signs shows how we can measure the word length that comes after it. Let me paste the pattern and explain. In this case, the hash character behind the word sunset is not matched because it's 6 character long. Those hashes which are highlighted are those with a word with 8 or higher length after them. This example is also as important as others. Each one demonstrate a new way of conditional match inside a text. Next sample text and pattern shows how we can find or match file names for certain file extensions. Let me paste the pattern. Inside the positive look ahead, literal.pdf and literal.html dictate the extension of the file name. In this example, only file name for PDF file and HTML file is matched and not the text file. Please pause if needed and exercise. Have a good understanding of these pattern is crucial. Let's work on another one example. First, let me paste the pattern. 4 digits for year is the target in this string. The look ahead is looking to find a dash. 2 digits. Another dash and 2 digits again. So none of the 2 digits are part of the matching and just creating look ahead condition for the year. As it was mentioned in the beginning, in look-arounds are zero-weight assertion and their characters will not be included in the match. Finally, the last example for positive look ahead. Let me paste the pattern. It's only looking for 1 or more digits with a condition. In this case, condition is if after that 2 digits are followed by degrees symbol, F, space, open parenthesis, the word heat, space and the word wave inside parenthesis. Although these are simple examples, but each one shows a different use case which we can face in real Reg-Ex scenarios. Now that I used many examples for PLA or positive look ahead, I will use less for NLA, PLB and NLB. Let's move to negative look ahead with some example texts. For NLA I picked only 3 sample texts. For the first one we are going to match prices without tax note. Let me paste the pattern. We are looking for literal $, 1 or more digits. literal dot. 2 digits for cents. But it should not be followed by open parenthesis. The phrase, with tax. Close parenthesis. In this example 0.75 is not matched as expected. For the second example we are going to match phone numbers without extensions. Let me paste the pattern. 3 digits. Dash. 4 digits. But it should not be followed by space. Ext. Dot. In this example the number in the middle is not matched because of the condition in pattern. Next example is a bit complicated. It's to filter transactions from financial data. Let me paste the pattern. The first part of the pattern is to catch price with $. Number. Dot. 2 digits. Next we are creating negative look ahead using question mark and exclamation mark. At the end we have a question mark and colon which create a non-capturing group which starts with literal open brace. In the middle we have a logical or between the words transfer and dining. In this example we catching expenses from any date inside the date sheet. And they must not be followed by words transfer or dining categories. As illustrated, prices from line 2 and 3 are not selected. Since this example is a bit complex, I encourage you to pause and exercise at your end. The next two items in the list follows the same logic but for the items which comes before what we are looking for. Look behind. Positive or negative are widely used in Regex. I start with PLB or positive look behind. There are two sample text and I have patterns for both. Let me paste the pattern for the first text. We are going to find words after Mr. or Ms. The positive look behind part is looking positively for Mr. or Ms. and a dot to match what's coming after. As illustrated, only Mr. Smith and Ms. Johnson are matched and not Mrs. Brown. In next example we are going to match the version numbers after V. Let me paste the pattern. In this positive look behind we are looking to find V before the actual numbers. So the version numbers are matched only if they start with V. The version number 4.0.1 is not matched in this example because of the condition in PLB. Now we move to the last part which is NLB or negative look behind. Again, two sample text and two patterns. In the first example text, we are looking for @ sign and the word after if. Let me paste the first pattern. It's an interesting pattern. It says I match if the character behind @ sign is not a word character or dot. In email address the character behind @ sign is a word character N. So it will not be matched. If I add an space between John and @ sign, it will be matched. I can try and add exclamation mark to match it. In the next example we are looking for the word book surrounded by non-word characters. As the pattern indicates, no word character can be before the word book. So if I add exclamation mark, it will work, but if I add number 1, it unmatches the word book. Let's take a deep breath. And there we are. We've reached the end of our journey through the wonderful, sometimes puzzling, but always powerful world of regular expressions. When we started, those strings of symbols might have looked like someone had fallen asleep on the keyboard. A jumble of backslashes, dots, and brackets. But now, I hope they look less like magic spells and more like tools. Precision tools for taming text. Because that's what you have now, a toolkit. A quiet superpower. While others are still copying and pasting, or manually sifting through line after line, you'll be able to write a single, elegant pattern that does the work for you. You'll see a messy log file, a poorly formatted export, a mountain of user input, and instead of feeling dread, you'll see possibility. You'll see the pattern hidden within the chaos. The real mastery doesn't come from memorizing every symbol, it comes from practice. From trying, from testing. From the small victories of a pattern that finally works just right. So take these patterns out into the wild. Use them. Tweak them. Break them and fix them again. Let them save you time on a tedious task. Let them solve a problem that's been bugging you. Let them bring a little bit of order to the beautiful chaos of language and data. Thank you so much for spending this time to learn. You've added a truly valuable and timeless skill to your repertoire. It's been a pleasure to guide you. Like and subscribe and leave me a comment. It helps to get a better idea about the next Reg-Ex training videos. Go make your text behave. Happy matching!